All right, we're going to pick up where we had left off yesterday. Remember, we're talking 9.4, which is composition of transformations. Yesterday, we talked on the coordinate plane, of course, where we just took a figure. We either, rotated it or we reflected it, and then we, maybe translated it after. But we just used two translations on the same figure in the coordinate plane. And so we looked at that yesterday. Today, we're going to look at composition of transformations in the, not in the coordinate plane, but just in general. Okay, and so the composition of two reflections. This is what we're going to look at here first today. The composition of two reflections. Okay. In a figure across parallel lines. We're talking about parallel lines here. Is the same as a translation from the first figure to the last figure. So the idea here, you start with figure P here, and we've got parallel lines K and L. These are parallel lines, right? If we do two reflections across these lines, if we reflect across K first, then we get P prime, and then we reflect across line L, so two reflections across parallel lines. Okay, that would be the same if you notice these figures, triangle P and triangle P double prime, are oriented in the same way. Okay, it would be the same as if we just translated it 2 times d, d being the distance between the parallel lines. So a double reflection is the same as if we were to translate the figure 2D. So interesting observation there. That's kind of the main point. It would be the same as a translation, right? A double reflection is the same as a translation. That's in parallel lines. Okay, now if we talk about two reflections in intersecting lines, this is two reflections in intersecting lines where we reflect across line K, and then we reflect across line L. So two reflections across intersecting lines. That would be the same as a rotation from the first to last figure. So, and that rotation would be, well, if those lines make x degree angle, the rotation, it would be the same as a double reflection would be 2 times x. All right? And so if we have intersecting lines, it's the same as a rotation. If we have parallel lines, it's the same as a translation. And so we're going to reflect a figure in 2 lines. We're going to copy and reflect figure A and line M, and then line P, and we'll describe this as a single transformation that maps A onto A double prime. So first we want to reflect it across M, so we'll take a point here. Again, we just want to go perpendicular bisectors. So we want to go maybe over here. Just trying to eyeball the distance, trying to make sure that the distance of that point from M to the other side is perpendicular, and again, we want to make sure it bisects. So actually, to be a little more accurate, let's move that a little further out. Here. All right, so then at this point, if we're reflecting that across, it's not too terribly far from M, so it won't go that far away. At this point, much further, so it's further than both points, so that one maybe over here. And this one pretty much lines up with that first point we reflected, so let's try to do that. And this would be our reflection across line N. This is the reflection across N. Again, I'm eyeballing this. You can do this very accurately with a ruler, but eyeballing it would be enough because we just want to talk about the single transformation that happens here. But we haven't done a double reflection yet. Now we need to take these points and reflect them across. So at this point, it's going to go a fair distance out here. Like this one. Eyeballing this here. It's really far from P if we're reflecting across P. At this point is very far from P. So put that over here. And And then lastly, this point here, take it again lines up with that first point we reflected, so we'll put it there. And this would be the shape double prime, a double prime. And again, the idea here is reflection across parallel lines is the same as a translation. And the distance of translation would be 2 times the distance between the parallel lines, which is 1.75. So 2 times 1.75, we'd be looking at 3.5. So 3.5 centimeters. All right. Yikes. This technology's always giving me trouble here. All right. So we talked about this. I'll leave this one to you guys. You guys can just reflect, you want to reflect each of these points in the triangle across M. After doing that, you'll reflect it across P. I think you guys are able to do reflections. And then after you did that reflection, you would have something that would look, like this. Just eyeballing there. Right. We did a double reflection. That's what we have going on. Put that across. All right. And so that would be the same as, again, reflection across intersecting lines. That is the same as a rotation. How many degrees? Well, it's 2 times the angle that's created by these lines, which is 60. So 2 times 60. That would be the same as a rotation of 120 degrees. All right. So here's a summary of composition of translations. Okay. Composition of, translations. So, and that'll wrap it up for us today. So thanks for watching. Again, we'll work on the homework for this lesson on Thursday in class, Wednesday being a PSAT day. So everyone have a great afternoon.